Hello, this is a video on molality and how to calculate molality, which is a type of concentration term. Molality is like molarity and most all of the other concentration terms, mole fraction, mole percent, mass percent, volume percent, where it explains how much solute you have to put into a given amount of solvent to make a specific solution, and that solution can be either saturated or unsaturated. Remember, there's no such thing, there's nothing else besides saturated and unsaturated, as long as you're just putting solute into solvent. Okay? It's unlike solubility, where solubility, it's only at the saturation point. When somebody talks about solubility, there is no such thing as like an unsaturated solubility calculation. Doesn't make sense. Molality is different from its cousin molarity with the R, with the symbol is big L, big M. This molality with an L, the symbol is small m with a bar on top of it. And the major difference is that molarity, big M, is solute information, specifically moles, over solution information, specifically volume. Here we don't have that because that's a ratio of part to whole. This is kind of like all the other concentration terms where we have part over part. In this case, the part is solute and the bottom is solvent. And for molality, it's a mass to mass pot. So this is kind of very similar to a mass fraction or mass fraction. Okay, so the small m bar is equal to the moles of solute. Okay, so you're going to have to change the mass into moles. So the actual calculation is small m bar is equal to moles of solute over grams of solvent. And specifically, it's in kilograms of solvent. Okay, so again, I can't show you on the little chart a bar. So you need to put a bar over this little m. Okay, and it's not a big M. It's actually a small m. That's a small m. Okay. So again, it's moles of solute over kilograms of solvent is the ratio. So there's an example, just like the other one. Here's an example of it. This is what the symbol looks like. Okay. So in this case, they want to know how many grams of the solvent do I need to add to a specific amount of grams of solute to make a specific molarity. Molality. So as you know, molality, this one here, is equal to moles of solute over kilograms of solvent. But what you want is you want a bottom piece, so you rearrange the equation. Okay, so as you know, you're going to eventually need to know, since you have moles of the solute, and you want to go to get rid of the grams of solute, then you need the mole mass. So therefore, what you can do is you can simply go here and plug it in here to find your moles of solute, because you need that there. So that's part of the declaring your variables. So therefore, what you're gonna then also have to have is the 0.840 molality, which is really moles per kilogram of water. These needed up here, so they cancel. So what you get is x is equal to this number over that ratio. When you flip it, okay, so technically you don't even need this this particular place right here. I'm using it to compare it to dimensional analysis, and you can plug it in, and what you get is sorry, you do need this because this is changing from kilograms to grams. So once you get out of this equation, you get kilograms. The question asks you in grams. So therefore, you need to change into grams, and it becomes 303 grams of water you need. Okay? And that's an example of how to do molality. You also, by equation, because you also can do it by dimensional analysis. So again, you know going to need the molar mass of the solute, because again, molarity and molality are moles of solute, and most of the times you're going to be given information in mass. Okay, so you're going to have the molar mass. Also, you need to be able to separate out the molality small m bar unit into their actual complex units, because you need to cancel out using dimensional analysis. So as usual, if you're in dimensional analysis, if your answer is one unit substances, you start off with 1 unit substance. So you start off with 25.7 grams. You want to change that into moles. So you need the relationship, the molar mass relationship. Get rid of the grams on the bottom, moles on the top. Now you have moles of the solute on top. Well, you're gonna just like molarity, your molality and all your concentration terms are basically conversion factors between one of the substances and the other substance, whatever those are, because all concentration terms are basically ratios. So in this case, this is your conversion factor between moles of the solute and kilograms of the solvent. So you put the moles on the bottom because you get a cancel. Now you have kilograms of water, but you don't want kilograms of water, you want grams of water because somebody asks you for the grams of water. So you change the grams of water, kilograms of water into grams of water, and you end up with this number, which is exactly the same number. So that's how you do it by dimensional analysis. Okay, and all of these can be done by dimensional analysis. Okay, I hope that helps you out.